So this is my fourth challenge that I've posted for you guys to practice on. I will go through some of all of these questions again for you guys, hopefully with some understanding on how to answer them. So very quickly, we've got another image question here. So again, obviously that's something we're going to go through and edit the pixels. We've got another one here to draw a particular shape. We've got this one where they're asking you to calculate the mean of a few given numbers. We've got another image one where it's asking you to crop an image. We've got another one with a set of numbers and it's asking you to find the highest number. We've got another maze one here and then we've got another maze one here as well. So hopefully you guys are a little bit more prepared with some of these questions, but we'll go through them very quickly anyway. So the first question, we've got the image shown is a PNG. Its pixels are defined by 4 values: red, green, blue, and A stands for alpha transparency, 0 to 255. Hidden in the blue data of the image is a secret code. Your task is to write a program to reveal the code word and then enter it as your answer below. So again, if anyone hasn't seen any of my videos, the way an image is made up, you have a grid of squares. These are called pixels, and pixels have its own color, and those colors put together create the image that you see in front of you. And you've got so many pixels that allows you to get this really round sort of circle. If I was to zoom in loads, you can start seeing the pixels there. So it's not very sort of round itself. It's just because we've got so many squares there, it looks like it's round. Anyway, so what we're going to do is we're going to go through each pixel and edit the pixels in order to get that secret code. So we're going to head over to image and we're going to use 4p in pixels. And what that does is that goes through each individual pixel and runs a bit of code on each pixel until it's done it for the whole image. What do we want to do? So we know that hidden in the blue data of the image is a secret code. So we need to edit the blue data in some way to try and get that secret code. So what we're going to do is, we know it's in the blue data, so we need to say that whenever the blue data is above or greater than some of the others, we want to do something to it. So let's head over into image and we are going to obviously get the B value, which is blue. But obviously we only want to do this for the ones where the blue value is higher than the others. So we're going to go into logic. We're going to grab an if statement. And remember, whenever we have an if statement, we need one of these statements to go with it, or one of these blocks that compare one side to the other. But if something is greater than the other, so if my blue is greater than, let's just say, greater than, let's head back there. Let's get another color. Let's zoom out of that a little bit. So if my blue is greater than my red, then we're going to do something to it. But obviously it's not just about the blue and red. We're going to head back to logic and we're going to grab this and. Let's duplicate that. Let's put one on either side. So if my blue is greater than my red and my blue is greater than my green, then let's do something with it. And what we can do is with those pixels which are more blue than anything else, what we can do is we can set them. So let's head back to image, and now we're going to set the alpha transparency, so how transparent it is, to, let's see if we set it to 255. So it's not transparent at all. Let's set it to 0 to make sure that there's so that it's transparent. So let's run that again, and that's anything which is blue. So you can see a couple of pixels being edited there as well. They've gone transparent, but this has gone transparent as well. That's revealed the secret word, which we can enter here. So salad. We can save that, and that's given me my answer as correct, what it should have done. Okay, there we go. Correct. Okay, so I can see that flower's there. For some reason, it's not telling me I'm correct, but I can see that I've got that flower there, which means I've answered that correctly. The next question we have here, one-line house. The house shown below can be drawn with one line without lifting the pen. The angles you may need are 45 degrees, 90 degrees, and 135 degrees. The line lengths you will need are 70.7, 100, and 141.4. Write a program to draw the house shown. So I think the first thing you need to do for this one, and I think this is a bit of a cheeky question, because you need to know how to do this yourself to start off with, in the sense that you need to know how to draw this shape without lifting the pen. And this is something that I used to do when I was younger, where you sort of challenge your friends and you'd have a go of trying to do it without lifting your pen off the paper. But this is something that you'd need to do yourself first. So I think it will be good to start off with a pen and paper, try and work out exactly what route you're going to take. So if I was to head up, across, down, up diagonally, get the roof done, and come back down, and then that little line at the end. That's one way I could do it. Or I can turn left, come down, turn right, and I can sort of, there's more than one way you can do it. But if I was to do that to move forward, so I can start off, let's come down here, let's zoom out a little bit. Okay, so if I was to move forward 100, let's run that. Yep, that seems fine in terms of length. Okay, and once I've done that, I'm going to turn right 90 degrees, I'm going to move forward another 100, turn right 90 degrees, move forward another 100. So now I'm here, now I'm facing downwards, I'm now going to turn right, and I think that's going to be 135 degrees. I'm just having a quick little go. Whoops, okay, I was meant to turn left. And obviously pointing in the wrong direction, and now I can move forward. I'm guessing that's one of my longer ones. So let's try 141.4. Whoops. Let's do that. Once we're facing there, let's turn, I'm guessing turning left 90 degrees. I'm guessing moving forward probably 70.7. Turn left another 90 degrees. Let's see how we do so far. Good. Now I obviously want to turn right, oh no, turn left again. Move forward another 141. Again, all a bit of trial and error. If we make a mistake, it's not a problem. We just need to recognize where we've gone wrong. Let's run that. Whoops. Okay, so I obviously wanted to turn right at the end. A bit more than that. There we go, all done, correct. Okay, bit of trial and error is all good. Now in this one, the mean or average of a set of numbers is found by adding them all up and then dividing by how many numbers are provided. So I've told you exactly what you need to do. You want to add them up and then divide it by how many numbers are provided. Complete the function provided so that it outputs the mean of any given 5 positive integers. So they've actually helped you out by telling you you'll only have 5 positive integers. So you can divide it by 5 rather than dividing it by, a variable, which is the number of numbers. So very easily, what we want to firstly do is add them all up. So let's head down to maths. And obviously we want this addition. We've got a variable here called mean. So find mean with A, B, C, D, E, and return mean. So we're actually going to set mean. We could create another variable called total, but I'm going to just use my variable called mean. And I'm simply going to set it to A plus B plus C plus D plus E. It's as simple as that, really. So let's get a variable in there, a plus, let's duplicate that, let's pop that in there, plus b, duplicate that, let's pop that in there, we've got c, duplicate that, put that in there, a plus c, a plus b plus c plus d plus e. So now at the moment, my mean is equal to those 5 numbers added together. Now all I'm going to do is set my mean to, again, let's head over to maths. Let's grab one of these here. I want to just divide my current mean by 5. And it says easy as that. So let's run that. 6.2. There we go. Correct. My answer is saved. Let's head over to our next question. So cropping. The pixels in the images below are defined by 3 values. Again, we know we've got RGB plus A. The first image is 200 pixels by 200 pixels over here. The second image has had the bottom 50 pixels cropped. So we can see we're chopping off those 50 pixels. So that now is only 150 pixels high. This is done by setting all the R, G, B, and A values that are no longer wanted to null. Write a program that transforms the first image into the second one. Hint, there is a null block in the logic folder. So we do have this null here. They've told us that we want to use it. So obviously let's use that. So again, if you saw my previous image ones, we are going to use 4p in pixels. And obviously all of these would have coordinates. So obviously we're starting off with 0, 0, and we're changing our x and y coordinates accordingly. So if you remember, x is going horizontally, y is vertically. So we're not really bothered about what the x coordinates are. We're worried about what the y coordinates are. And the moment the y coordinate is greater than 150, that's when we want it to become null in terms of RGB and A values. So what we're going to say is 4p in pixel. So we're going to get the coordinates. So we've got get coordinate, and we want to use the y coordinate in this case. And we're going to say that if it's greater than 150. So if you imagine, just think about what you'd actually do before you try to code it. Think exactly what you want to do and then try to convert that into code. Again, when we've got an if statement, we want one of these over here. If my y coordinates is greater than, let's put that number there, 150, then all we want to do is we can now set, so if y coordinate is greater than 150, we should be able to just set the r value to 0. Oh, to null. Duplicate. Now, one thing I can see here is that it says if the value is greater than 0, that shouldn't cause a problem, but let's test it out anyway. R, G, B, and A. Let's set them to null. Let's run that. And that looks like it's correct. There we go. So if that y coordinate is greater than 150, we're going to set our R, G, B, and A values to null. So next question, maximum, similar to the previous one. Complete the function provided so that it outputs the largest number from any given 5 positive integers. So again, if we're given 5 positive integers, we want to see what the highest integer is. Do not alter any other blocks provided. So just think about it. If I was to give you these numbers on a piece of paper and tell me what, I'll ask you to tell me which one is the highest, you might start off by, you can see straight away that it's 12. But we can run through that in our head and think, how would we do that step by step? I might start off by see what's higher, 5 or 12. 12 is higher. What's higher, 12 or 7? 12 is higher. What's higher, 12 or 7? 12 is higher. What's higher, 12 or 0? 12 is higher, so the answer is B, 12. So that's one way we could do it. And what we would do is basically convert that into code. So again, think about how you do this if I was to give these questions to you on a piece of paper. So we're going to start off with our if statement. So let's head over to logic. And then what we can say is, do we have a variable here? We've got a variable called max, which is what we're going to return at the end. And we can start off by saying if, and obviously we want to head back to one of these logics to say if A is greater than B, then what we're going to do, we're going to use a do, and we're going to say else. Okay, so if A is greater than B, then what we're going to do is we are going to set max to A. Otherwise, what we're going to do is we're going to set max to B. All done. So in that case, what we've done is we've compared A and B. Let's just move this to this side. We've compared A and B. If A is higher, we're going to set A to max. Otherwise, we're going to set B to max. And what we can do is we can simply duplicate this and now say that if C, because we've compared A and B, if C is greater than max, because now we've got a variable in max, which at the moment is 12. If C is greater than max, then what we're going to do is we are going to set max to C. And if it's not, then we can actually leave max the way it is. So we're actually going to get rid of that else, and we can bin this. Okay, so now at the moment what we're doing is we're checking is what is 5 greater than 12. If it is, set max to 5. Otherwise, set max to 12. We're going to set max to 12. Now we've got max as 12, so we're saying is 7 greater than 12? If it is, then set max to C. So now set max to 7. It's not, so we're going to keep it as 12. Now I can actually duplicate this. I can actually duplicate this twice. Do the same for D. And do the same for E. And what that will do is that will run through everything there and tell us exactly what is the highest. In this case, it's 12. And that's told me, oh, that's incorrect. So obviously I've made a mistake somewhere there. So find maximum if a, oh, I've used equals there. I need to actually change that to greater thans, all of them. There we go, 12. There we go, correct answer is saved. Now the reason why that didn't work is it said is A equal to B, which it isn't, so it did set that to B, and obviously C was not equal to it, neither was D or E. And that's why it returned it to 12. But it does obviously check it as needed, even though it did return the answer 12. Obviously it wasn't the correct code, so it did tell me that I was incorrect, but great, it's told me I'm correct now. Let's move on, Wrigley maze. Again, how would we do this maze? Now we can see that this one leg is set the same as this second leg, and then this third leg is half of that. So we can think about how we would get from this point to this point so that it's practically in the same space, just a little bit further down, and we can repeat that 3 times. So what I'm going to do is I'm going to go to repeat. I'll get this to this side first, and again this is the same as going this way. So 1, 2, 3, 4, 5, 6, 7, 8. Looks like 8 there for me. So let's repeat this 8 times, move forward. Let's test that out. Okay, didn't look like that was correct. So let's change that to 9. And that seems to take me where I want to go. Once it's repeated that and it's got to that end, all I'm simply going to do is I'm going to turn right, move forward, and then turn right again. And now I can repeat this repeat loop again. And once I'm at the end here, I'm going to do the same. I'm going to turn left, move forward, turn left. And then I could do the same thing again. I can actually put that in a repeat loop. Oops. 3 times. I could run that. Let's speed that up a bit. There we go. Easy as that. Let's move on to the next question, final question. The genie needs to go back in its bottle. So we've got the genie here, bottle here. Write a program in the workspace below that gets it to the genie gets the genie to the green square. Your program must be made from 16 blocks or less. So again, we've got a constraint there. So if we look at, I've got a function here, so to do something, return, okay? Or I've got my movements. Now, I do have if path ahead, it can do something. Problem is, if I go up this way, it will not stop. If I put it in a repeat loop, it will not stop there. So what I will do, obviously it is difficult for it to sense this, unless if I get it to go just a few bit, halfway up there, then turn around, I can say if there is a path to the right, but it will detect these. So I'm probably better off just sort of coding it individually. So I'm looking at 1, 2, 3, 4, 5, 6, 7, move forwards. Okay, unfortunately, I cannot use a repeat loop. 1, 2, 3, 4, 5, 6, 7. Let's pop them all in. Let's make sure that runs well. Yep. And now what I can do is I can now turn right and I can move forward 1, 2, 3, 4. 1, 2, 3, 4. Now what I can do is I can turn right again. I've got 7, 8, 9, 10, 11, 12, 13. And I could just simply say, now we can repeat, move forward. And we can run that. And there we go. So that one's fairly easy as well. So I hope you've been practicing my quizzes. I will post a link to this quiz as well in the comments. So please do give that a go if you're able to. Also, just let me know how you get on. If you get stuck with anything, feel free to post a comment and I can respond to that. And I will hopefully post a couple more as well. Anyway, thank you very much.